In the last video, I discussed the importance of pattern recognition and demonstrated how a simple neuron could perform it. But of course, in doing this, I set the weights of the neuron using common sense and by hand. In reality, this is done automatically via the learning or training algorithm. At this stage, I'm not going to do any serious analysis of learning algorithms. Just give an intuitive example to let you see in a common sense way how one might work. Firstly, however, let me say that there are different types of learning or training algorithms, and we'll meet these as we go through the course. But the type I'm going to describe here is perhaps the most common and is called a supervised training algorithm. In supervised training, the network learns patterns by example. We give it examples of the patterns we wanted to recognize, for example, the letters of the alphabet, and we tell it what output we would like it to give for each pattern. These required outputs are called targets. A pattern and its corresponding target is called a training pair, and a whole set of these is called a training set. For example, in the system described in the last video with 4 pixels, a training pair is shown in the diagram on the screen. But let's say that we add an extra neuron to this system. We could then set it up so that it recognizes 2 patterns. One pattern programmed into neuron 1 and the other pattern programmed into neuron 2. In this case, the training set would look similar to that shown on the screen. So the idea here is that we use this training set to teach the AND these patterns and the outputs that we want for each one. And after this process is over, the weights are fixed, and if we put in a pattern again, or even a corrupted version of a pattern as we've seen, the AND will respond by telling us which pattern it is. As an example of this, there could be 26 patterns corresponding to the 26 letters of the alphabet, and 26 corresponding targets, the outputs that we'd want for each pattern. This would be a training set for the entire alphabet. So how could an algorithm be structured to change the weights approximately to do this? Well, at a simple level, this could be as shown on the screen. Firstly, if the output is correct, that is, it's equal to the target, do nothing. We've already got the network trained for that target. If the output is too high, that is, the output is greater than the target we want, then decrease the weights attached to the high inputs. If the output is too low for that particular pattern, then increase the weights attached to the high inputs. So it's really just common sense. And real learning algorithms just take ideas like these and codify them into mathematical terminologies which we can program into a computer. Often, once a network is trained, or sometimes as it's been trained, it is tested with a random set of examples. These are used for only testing purposes and not training, and are called the validation set. Once the network performs well enough on these test patterns, training is stopped. However, this is only one way of stopping training. There are others as well. The most common supervised training algorithm is called backpropagation, and we'll look at it in a couple of videos' time. The part of the AND algorithm which changes the weights to train a network is called the reverse pass.